Okay, so now welcome, and in this example we're going to find the surface area of a sphere with radius r. Okay, so in other words, we're going to use the techniques and we're going to use the formula for, we're going to use integration to find the formula for finding the surface area of a sphere with radius r. Okay, so we start by knowing that we have these parametric equations. X of t is equal to r sine t, where r is the radius, and y of t is r sine of t, where again r is the radius, and we're going to integrate from 0 to pi. So the integral is from 0 to pi. So that's the value for our parameter t. Okay, so I just sketched the graph. So this is again just the graph of the curve. So this is what we're going to find. We're going to take the arc length, and we're going to take the arc length and we're going to revolve this thing around the x-axis, right? So we're going to go around the x-axis and come up with the surface area of the solid that's generated by that revolution. Okay, so now let's take the formula. So the formula for the surface area is going to be equal to the integral in this case, it's going to go from 0 to pi, and it's going to be of y of t times the square root of x prime of t squared plus y prime of t quantity squared dt. Okay, so now let's plug in our information. So this is going to be an integral from 0 to pi. Y of t is equal to r sine t. Okay, now x prime of t is r, negative r, so negative r sine t squared plus then the derivative of y, which is going to be r cosine t quantity squared dt. And then just like before, we're going to get something nice that's going to happen. This is going to be 0 to pi. We're going to get r sine t, that's going to stay there, so r sine t times the square root, and what happens in here? We get r squared times sine squared. We get r squared sine squared t plus r squared cosine squared t dt. Okay, so all I did was distribute the powers, and so I got this. Okay, now this is going to give us the integral from 0 to pi. Now I'm going to factor out the r squared. Okay, so I'm going to take r squared and that's going to give me the square root. I'm going to factor out r squared times sine squared t plus cosine squared t dt. And again, this is the Pythagorean identity. So this is just going to equal 1. And so now this becomes the integral from 0 to pi of r sine t times the square root of r squared, right? Because this is just 1, so I just get the square root of r squared, which is just r, right? That just gives us r. So I'm going to get the integral from 0 to pi. When it's all said and done, this r times this r is just going to give me r squared. So I'm going to get r squared times sine t dt. Okay, so now I can integrate. Well, what's the integral of sine t? Well, that's going to be negative cosine. Right? So it's just going to give me negative cosine. Oh, I dropped my, I dropped my 2 pi. I didn't put my 2 pi here. 2 pi, sorry. 2 pi. Don't drop your 2 pi's. 2 pi. 2 pi. Okay, there we go. Okay. So now, what do I get? I get this. I get 2 pi times, oh, hold on, 2 pi r squared. 2 pi r squared times sine t evaluated from 0 to pi. So this is going to equal 2 pi r squared times sine cosine. Sorry, this is negative cosine. Negative cosine t. Negative cosine t. Okay, so this will be the pi, so this will be negative cosine of pi minus cosine of 0. Right? So that should be, that's correct. But this should be plus, right? Okay, now, so what is cosine of pi? Well, cosine of pi is negative 1. So cosine of pi is negative 1, which the negative of a negative 1 gives us positive 1. So this is going to be 1. Okay? And then cosine of 0 is 1. So that's going to be 1. And so our final result is what? It's going to give us what? 2 pi r squared times 2, which gives us 4 pi r squared. And that is the formula for finding the surface area of a sphere of radius r. And that's it. Have a great day.